Good morning, my good people. So today, this video, we're going to talk about our first macromolecule, and those are what we call carbohydrates, right? Carbohydrates are probably the ones we're probably the most familiar with, right? They're in everything that we eat, bread, rice, sugar, anything that is basically a flour or sugar, it's a carbohydrate, right? So this is what we see, this is what we kind of consume. These down here are what, if you were to zoom in on like a grain of rice or a sugar cube to the atomic level, this is what we would actually see composing and making up these rice grains or these sugar cubes. So before we get too far, just some basic terms to keep in mind as we go about, right? So all of these macromolecules, they have like two parts to them. They have the monomer and then they have the polymer. The monomer is the basic building block for longer chains, right? If you want to think about it, right, these root words are going to be really important. Mono is one. Mono means one. So glucose, this is what glucose looks like on the atomic level. This is what fructose looks like. Polymers, on the other hand, are these longer chains of compounds that are just stacked or just combined monomers. So if we have multiple monomers combined together, we get a polymer. Sucrose is a polymer. We took glucose and fructose, stuck them together, and we get sucrose. Polyvinyl chloride, or PVC as we all know, is this. This is all PVC is. These brackets down here and this N just means that PVC is just repeating chains of this. So all the PVC is just repeating chains of this. So this is the monomer, and then when we stick them together, we get the polymer. All right, moving on with carbs, right? Carbohydrates, the basic structure, really are made up of three elements, right? Carbon, hydrogen, oxygen. That's all carbs are: carbon, hydrogen, oxygen. All right. If we look at it as a linear structure, it's just repeating chains of this. Carbohydrates can also form in a ring structure, right? So this is that ring structure here. Just as a reminder, right? When we get structures like these bonds or these little kind of corners that you see, at each corner is a carbon. So carbon's here, carbon's right here, here's a carbon, here's a carbon, here's a carbon, here's a carbon. So the basic form of carbohydrates are sugars. That's all carbs are just sugars, right? And we call those saccharides. So saccharides, of course, monosaccharide just means one. Disaccharides if we have two or more, and then we can even get polysaccharides, which are just many, right? So glucose, again, favorite guy, glucose. Fructose, these are monosaccharides. Mono means one, saccharide means sugar, one sugar. That's what we got here. Disaccharides are just two monosaccharides joined together. Again, sucrose here. Sucrose is what we find a lot in table sugar. Glucose and fructose combined together. Lactose, this is what is a lot in milk. If people are lactose intolerant, this is what they're unable to digest, is right here, right? And all this is two glucose molecules just stuck together, right? So again, we have the polysaccharides, which are many monosaccharides joined together in a chain. Cellulose, so a lot of plants have cellulose. We as humans or mammals can't digest cellulose. Our bodies physically can't digest it, right? So all cellulose is just this compound here, these ring structures, and just in a long, huge chain. That's all they are. Amylose, all right, amylose, it's just repeating chains of this over and over and over again. All right. Monosaccharides can be joined together to form longer chains. Polysaccharides can be broken down to form shorter chains. All right. A little trick, right? We're going to go through carbs and proteins and lipids and nucleic acids. A little trick to help you identify, is this a carb or is it a protein? Carbs, most carbs, are going to end in this ose ending. Amylose, cellulose, lactose, glucose, fructose, sucrose, right? So this ose ending indicates, that's a quick way to check, hey, this is a carb. Why do we need carbs? That's where our bodies get the majority of its energy from. All right. This breaking and forming of bonds to break polymers into monomers and then monomers into polymers, it just happens over and over happening in our bodies right now. To break polymers into monomers, this is where we get a lot of our energy release from. It's through a process, a reaction called hydrolysis, and that's right here. So hydrolysis, what it does is we take a water molecule, we take H2O, and we insert it into our polymer. And what this does is it's able to break a bond and break them apart to form the individual monomers. All right. So if we want to think about it with our sucrose here, right? Our sucrose, hydrolysis would come in with this oxygen. H2O would come in, would break this bond, leaving an OH on one side and an H and another OH on the other side. All right. So that's how that works. The opposite, we call it dehydration synthesis. So we break that word down. Dehydration means we're removing water. Okay, that's how we get monomers to form polymers. By that removing of water, removing, two H's and an oxygen, we're able to form bonds here. All right. So make sure you kind of keep that in mind. Hydrolysis breaks polymers into monomers by adding water. Dehydration synthesis forms monomers into polymers by removing water. All right. So that's really the basics of carbs. All right. That's what carbs are. That's what they look like. That's what they do. Okay. That's the end of this video. If you have any questions about carbs, feel free to either next time you see me in class, ask me that question. So make sure you write it down somewhere so you don't forget it, or shoot me an email. All right. Other than that, have a great rest of your day, and I'll see you all in class next time. Have a wonderful day, my good people.